Recording started and I am sharing the screen as well. There you go. So you should be able to see my screen, right?
Yes.
Okay. Routine maintenance is a lesson in which we will learn what are the things we need to regularly check or regularly perform on the server, what maintenance activities so we require to perform on the server. So that is what we are going to learn in this lesson. Okay. So this lesson, so database maintenance is a very common activity for DBS. Any database you take, so time to time it requires some maintenance. So without the maintenance, what happens, the database will become slower, it will become, heavier, so bulkier than, actual data it contain. So the physical size will grow. So, such problems are common in all databases, particularly in Postgres. These commons are even more, these problems are even more common and severe. So the reason why is, in during the architecture lesson, we learned about, dead tuples, dead tuples, and, the live tuples are dead rows and live rows. So Postgres, the old rows Postgres does not delete those old rows. So the deleted rows remains physically in the data files, and the rows which are updated also remains physically. The old version of the row physically remains in the data file. So that will cause the bloating in the Postgres data files, table data files. It causes the bloating, right? So, there will be a lot of stale data or dead tuples. So, and we should be time to time, we should be performing the maintenance. Postgres on its own never cleans that. Okay, dead tuples. It never cleans the dead tuples. It will go on creating the dead tuples for every every delete and update you are doing on the system, but it will never ever clean up that. Okay. So, that is what, the problem with the Postgres. So that's the reason, we need to perform regular maintenance on the Postgres database. Data files become fragmented as data is modified and deleted, right? So that is what. So when you delete or modify, update the data, the old version of the row so still remains in the data file. Though, it is not visible to the queries, but yet it remains. Okay. Database maintenance help reconstruct the data files. You can recreate those data files, reconstruct the data files, remove all the free spaces, remove all the dead tuples, and you can trim your data files. So you can, shrink the size of your data files. So through maintenance activities. So if done on time, nobody notices. Generally you have to do on time, because, if you don't do on time, so everybody started feeling that, the database response time is slow. So every user will start feeling that. So because, if you don't perform the maintenance activity at a regular interval, so manually or through the jobs or whatever means, we need to perform the maintenance activity. So if we are performing on regular basis, so nobody notices. Otherwise, what happens is, the people will notice that, there is something wrong with the database. Okay. So because their queries are taking more time, they are running longer than expected. The response time of server will become slower. So must be done before you need it. So it's not that, when the data file is bloated, so you should do something about it. So you have to be proactive and do something about it before it gets bloated. Okay. So maintenance activities improves the performance and, saves database from the transaction ID wraparound failures. So this was a problem in the older version. Transaction ID wraparound problem was so there in older versions, but newer versions of Postgres, particularly 12, 13, 14, they are more robust and they are immune to this transaction ID. So wraparound issue. Okay. So we will see what is the transaction ID wraparound and, so how Postgres deals with it. So, whether you need to worry about it or not. So, during this lesson, we will also know this one. So, this transaction ID wraparound problem is very unique to Postgres. Other databases does not have this. Okay. Like, other databases also does not have the issue of dead tuples. So, dead rows. So here, other databases does not have the issue of transaction ID wraparounds. So these are the some of the reasons why we need to perform the maintenance on regular basis. Okay. So, if you want to perform the maintenance, you require some tools, right? You need to run some commands to perform the maintenance. Every database gives commands to perform the maintenance on the data files on, so tables on, every database provides certain commands. Compared to other databases, Postgres provides only few and they are enough for maintenance. So you don't need many here. So there are only few commands for doing the maintenance. So PostgreSQL maintenance thresholds can be configured in PostgreSQL.conf. The maintenance activity automatically done is through auto vacuum. So the auto vacuum thresholds can be set in PostgreSQL.conf file. So manual scripts can be written. Okay. So, there is a view. Actually, it is not a table, but it is a view. PG stat user tables. So PG stat user tables. So there are so many tables. So probably tomorrow we will learn about, this main monitoring. So then we will come to know about more about these tables. So maybe I need to just reset, exit. For HTTPD service, so we didn't discuss it earlier. So, so we didn't discuss it earlier. HTTPD service is there. So that is responsible for, our PG admin. So if the PG admin is not running, so that could be because, HTTPD service is not running. So it is a Apache web server service. It is. So it is running fine. So, our web server also should run. Okay, maybe the IP address has changed. 23.24.172. Okay, the IP address has changed. Usually on the production servers, so we don't have these issues, right? So on production servers, we will get fixed IP addresses and we don't have any issues at all. Okay, so let me connect here to any database, either MyDB or Postgres, any database you connect. So go to the schemas. Okay, sorry, go to the catalogs, not schemas, catalog. In that, you have this PG underscore catalog. So it is a special schema containing all what we say means uh, objects, system objects. Okay. So we will see about the views. In the views, so at certain point you have the stat activity, PG stat views. So these stat views are very, very helpful in knowing what is happening on the server. So one of the utility service is there called as stats collector. We have learned great deal about the stats collector last week. So the stats collector service is responsible for collecting these tables, maintaining these views. Actually, they are not tables. So they are not tables, they are views. Okay. So one of the view is one of the view is PG stat user tables. So this view contains information about the user tables. So you have also sys tables. This view contains the information about system tables like PG class, so PG database, PG underscore table spaces. These are all, system tables, right? So if you want to know more about, the state of those system tables, you can check into that. So user tables means user specific tables. Okay. So likewise, if you have for indexes, you have sys tables, you have sys indexes, you have user tables, user indexes, user functions. So you have these views separate for user tables and user objects and a view for system objects. So, this PG underscore stat underscore user underscore table plays a very crucial role in actually identifying so which tables requires maintenance. So you can query that. So return all rows, you can query that view and you can see what is in it. Can you see this or better I query it? So from the command line, so I think that is better. Okay. So I'm connected to the Postgres database. I have done an extended display on, and then I am running the select statement. So T1 table, it is now giving information about our T1 table. So user tables, but that's the reason only user tables will be there. So no other tables. So I think we have two user tables. So T1 tables, this is the rel ID. It is the OID of the table. Name of the schema where the table is relation name. That is rel name is relation name. So sequential scan is 13. So that means, we have performed sequential scan, that is full table scan. So the sequential scan in Postgres is nothing but full table scan in other databases, like particularly Oracle and SQL Server, we use this term a lot, full table scan. In Postgres, we use the term sequential scan. Okay. So 13 times we did the sequential scan, that is full table scan without using index. So this will indicate how many sequential scans are happening on the table. So that gives an idea to you, whether, the table has effective indexes or not, right? The table has effective indexes or not, you will get an idea from here. So sequential tuples read how many times, it has read the tuples. So index scan, how many times it has performed the index scan? None. It is null now. The reason it is null now is we have no index on the T1 table. There is no index on the T1 table. So, no index scan is ever performed on that. Okay. So there are other things like n tuple inserted. So how many rows are inserted so far? N tuple updated. So how many number of tuples are updated since the table created actually? Most of these statistics are since the table has created. Okay. N tuple deleted, that means how many tuples or rows are deleted. Okay. So there is one option which I am particularly you should be so look into that is n live tuples. N live tuples tells you how many live tuples are there, and n dead tuples tells you in the table how many dead tuples are there. So from here you can find out so whether your table has any bloating dead tuples or not. Okay. So dead tuple is bloating. It is a unused space. Okay. So n dead tuples, that is how many dead tuples are there? That dead tuples are there. So right now we are good. Actually, we don't have any dead tuples in T1 table because we never performed any delete or update on that. So that's the reason, there are no dead tuples at all. Okay. This table is this view is one of the good view to start looking into. So whether a table requires whether a tables requires maintenance or not. So you can decide that from there, or you can write any script with Python or, shell script or any other script you can use to, so schedule the maintenance task also. So manual scripts can be written, so which can read these PG stat user tables. Okay. So, and then take the decisions accordingly and decide whether the table requires a maintenance or not. Okay. So what maintenance we can perform? So Postgres have limited maintenance options. So whatever kind of problems which exist in the Postgres can be resolved by these maintenance commands. So these problems are So these tools are, four tools: analyze, vacuum, cluster, and reindex. So these are the four tools we have through which, you can perform the maintenance. So the last one, reindex, is to perform the maintenance on indexes, not on the tables. Okay. So, so we have analyze and vacuum. So, and cluster. So we will see these things. So we will see these things now. Okay. Okay. There is a command called as vacuum DB, which can be executed from the command prompt. From the Linux command prompt, you can execute the command vacuum DB. So that also performs maintenance activities for us. Okay. So there is an auto vacuum that helps us in what we say means in database maintenance activities. So the vacuum, already we have learned about vacuum, right? So why we need to perform the vacuum? So the auto vacuum always performs the vacuum for us. And there are a lot of parameters to control the vacuuming, auto vacuuming. So we will see those parameters and what you can do, what you cannot do with the auto vacuum. So that also we will see. So, and also we will see about the vacuum DB command, which is very useful if you are writing any shell scripts to perform the. So shell scripts are batch scripts in Windows to perform the activities. Okay. So let us get started with, the maintenance activities with optimizer statistics. So long back last week, we discussed that, there are two types of statistics in Postgres. So there are two types of statistics. The first type of statistics is the usage statistics. Usage statistics is, just now I have shown in that uh, user view, right? Stats user view. So that shows how many inserts are done, how many dead tuples are there, how many live tuples are there, how many updates are done, how many sequential scans are done. So that is usage statistics, right? So how the table is being used, so that is usage statistics. The second type of statistics in Postgres is optimizer statistics. Optimizer statistics. Optimizer statistics is the statistics which are used by the query planner and optimizer to take decisions how to execute the queries. So which method is best, sequential scan or index scan, which method is best? So that is what optimizer statistics is about. So optimizer statistics plays a vital role in query planning. So they are there only for, the planner to generate the plans and the optimizer to, select the best plan to execute the query. The problem with the optimizer statistics are they are not updated in real time. They are not updated. So always you may have outdated statistics. So the optimizer statistics may be outdated. So collect information for relation, including size of that relation, row counts, how many rows are there, average row size, row sampling. So this information is collected and this information is stored permanently in the catalog tables. So the statistics are saved permanently in Postgres. Okay. So how you can update the statistics is, how you can work on the statistics is, so there is a command called as analyze. So this command help us in updating the optimizer statistics. The statistics which are required by the planner, query planner and query optimizer. So, they require the updated statistics. So to generate efficient query plans and to select a very effective query plan, so which can run faster than other plans. That decision depends on the availability of up to date statistics. Okay. So if your statistics are up to date, optimizer will take a good decision in selecting a plan, so which executes the query faster. So if your statistics are not up to date, then so the query plans will not means the optimizer is misled and selects a plan which slows down the query. So that is what the optimizer statistics are for. And actually optimizer statistics can be simply what we say means updated by running this analyze command. So let me show you this analyze command. So for example, so where these statistics are saved. Okay. So optimizer statistics are saved in a stats table. So in the catalog, we are looking in the views, right? So we are looking under the views. Instead of views, you go to the tables. So there is a table called as PG class, which we are familiar already. And also there are tables called as statistics. PG statistics, PG stat ext, PG stat ext data. So these three tables contains, the contains or saves the optimizer statistics. Apart from these three tables, we also have I think two or three views as well. Okay. So all the what we say means statistics, optimizer statistics are saved here. PG statistics, PG stat ext, PG stat ext data. Okay. So these are the three tables where it saves, and other table is PG class. PG class also saves some statistics. So for example, let me show you what PG class saves. Select rel name, comma, what columns it got, PG underscore class. Okay. So, and then, I want to show you what columns this PG class got. Okay. So there are two columns where, some statistics about the tables are stored. These are optimizer statistics, rel pages and rel tuples. So rel pages and rel tuples. Okay. So what we got here is, the rel name is T1. Rel pages are 0 and rel tuples are how much? -1 we got. So if you do a select on the T1 table, select star from T1 table. So what you can tell me here, or rather I will do it again. So what you say here? So our statistics says that, rel pages, that is, the blocks, disk blocks, totally there are 0 disk blocks are allocated for this table. And total number of rows in the tables is -1. Okay. If I do a select star from T1, so, I get this data. I have 2 rows in that, right? I have 2 tuples in that. Okay. Whereas here, total number of rel tuples, it is saying -1. So that means what? Anybody can tell me what it means? What this output suggests me?
It's -1 means infinity, like that.
It suggests that, the statistics are not up to date, right? They are outdated or they are not correct. We don't have correct optimizer statistics for this T1 table, right? Agree? So because, it says total number of rows are -1, but we have 2 rows. It must show 2, number 2 here, because we have 2 rows, right? And it is showing -1. So it is showing some incorrect values. So that means, the table statistics are so incorrect. So we need to correct those statistics. So how can I correct those statistics? Analyze command. Every database have the same analyze command as far as I know. So most of the database have the same command, right? In Oracle also same command, right? So to up to date the update the statistics, correct? So in Postgres it is analyze command. So analyze T1. So I'm saying analyze. So T1 table. So just run this command. So it will complete the analyze. That means it will gather the statistics, recalculate the statistics again. So after that, you run the same query. So you run the same query on the PG class table. Okay, because I want to verify the statistics, how accurate they are. Now what it is saying, now it is giving me accurate statistics. There are 2 rows in the table. Exactly, there are 2 rows in the table. And the rel pages, one block is allocated. I said when you do the first insert, it will allocate a 8 kilobyte block. And for this T1 table, so 8 kilobyte is a very, very large space because, it has just 2 columns. So hardly the size of these columns may be hardly few bytes. So not even kilobytes. So we are talking about, so 8 kilobytes. So, one block is allocated, one 8 kilobyte block is allocated for this data file of this table, and there are 2 rows in this table. Now I am getting accurate statistics, correct? Agree, everybody? So that is what the analyze command is. So you can also use analyze command to so statistics are calculated at a table level, like how many tuples are there, how many rel pages are there, how many rel tuples are there. So rel pages, with the rel pages you can also estimate the physical size of the data file. So if you have accurate rel pages, right, like in our case, so on the T1 table right now, so you can estimate what is the physical size. You can know the physical size. So how can you know? Simply you multiply the rel pages with 8 kilobytes. Okay. So you can see here, it is 8 kilobytes in size. So you can always get the size of the table by multiplying the rel pages, but always remember, so these statistics may go outdated very, so easily. So why? Because the statistics, the optimizer statistics are not calculated or gathered in real time. So they are gathered by auto vacuum, or they are gathered if a user runs analyze command. So if the user runs the analyze command, the statistics are gathered, or the other way is, they are gathered by auto vacuum. Auto vacuum also so does the optimizer statistics. So hope everybody got this point. Any questions here?
Yeah, suppose if there are 5,000 table
Yes.
and if a stat is not updated,
Okay.
in that case, will I get again -1 or some other figure other than 5,000?
Older,
Real
let us say,
tables.
older. After this too, after this, so for a very long time, the stats are not updated.
Uh-huh.
Then what happens is, still it will be showing data file. So rel pages is 1 and rel tuples is 0, 2. So it will be
Two.
still showing
Okay.
this old values.
Okay, so now value is 2. So unless if we don't do update, it will be 2 only, right, in the records.
It will be 2 only in the record. So let
Okay,
me
I
insert
understood.
something here. Insert into T1 values. Okay, so we have 30, so 40. So two more rows I am inserting. Okay,
Okay.
four rows are there. And now I will run the same query, this query, right?
Right.
So what it is showing?
2.
Yeah. So it is still showing the old, right? So it is
Right.
still showing the old one. Okay. So what I need to do here is, what I need to do here is I need to again analyze to get that thing to, update itself. Okay. So now it
Yes.
is reflecting correctly, right?
Yes.
Exactly.
Yeah.
So, that is what the statistics is. So in the PG class table, which we are examining now, so we have only the table level statistics, the number of rows and, number of blocks, how many blocks, how many rows. But the statistics are collected per column, the statistics are collected. For each column, the statistics are collected. For example, if you have a numeric column, so the statistics are also collected for that numeric column as well. And if the statistics are for if there is a string column or a text column, the statistics are collected for string column, text column, date column. So all types of column, for each and every column, the statistics are collected, which is very important, because the query estimates depends on the statistics. If you run any query, so if you run any query like select star from, so t1, where, so name is equal to, let's say, bbb. Okay, this is the query I am doing. So how many rows this particular query is going to return. So there is a estimation is needed for the, by estimation is needed by the optimizer to take a decision whether to use an index or not. So whether to use an index or not in this case, so estimation of how many rows this query is going to return, so that should be there. How it is going to estimate, that is individual column level statistics. For both the columns of the T1 table, it will gather the statistics and save the statistics in PG statistics table. So it's a catalog table, PG statistics, so which saves the column level statistics. For each column, it will be there. If it is a string column, so like our name column, so text column, so it will save the histograms, like each of the value, how unique it is, how unique the string values are there in that column. And if it is any column like a salary column, so in salary column we have different salaries. In salary column, it will divide the table into, divide the salaries into ranges, like salary 0 from till 0 to 1000 to 2000, 2000 to 3000. So these we call it as buckets or ranges. So it will divide that column into the salary, and it will then categorize in each of the bucket how many rows are there. So with that statistics, it will be able to estimate. So when the user runs the query without reading the data file, it will be able to estimate how many rows this query is going to return. So this estimate is crucial for optimizer to decide the plans which uses the indexes or the plans which it does not use the index. So column wise statistics are maintained. So when you run the analyze command T1, so analyze T1, actually the table level statistics plus column level, all the statistics are gathered. Sometimes if the table is very large, it may take some time. Okay, it may take time to complete this process. So okay, though the analyze is not a blocking act, it is a blocking activity. So but it is not a seriously blocking activity, so that others can still go about doing their transactions. Only few blockings are there, like others cannot modify the tables and all. So that type of blocking, when we go to the locking and transactions, we will see what are the levels of locks we have. And so when those locks are applied, so here the thing is, this analyze command has some overhead, some blockings it will do. May not be the DML statements. The DML statements are not blocked, but some other statements, DDL statements, some other statements are blocked while the analyze is running. So on very large tables, the analyze may take some time, but not a very big time. So because it won't read the entire table, max it will read, it will sample. So there is a sample threshold. So max sample is 10,000. Okay, rows. That is the max sample. Okay. So so here uh, if you want to calculate the statistics or gather the statistics for any particular column, so you can do that. So for example, okay, so you have this analyze command syntax. So you can also do a verbose if you want to know what it is doing. So you can use skip lock to indicate, if the table is already locked, don't touch it, skip it. Okay. So you can give table name and the columns also you can give. For example, so I can analyze like this. So I am analyzing only name column in T1 table. I am not analyzing the ID column. If you have more columns, you can also give column names. So you can analyze what we say means entire table, or you can analyze so a particular column. So if you are analyzing a particular column, so it will end fast. Okay. So that is about analyze. Any questions if you have, you can ask me now. Okay, I'm taking that as no questions. So we'll go to the next topic called as data fragmentation and bloating. So data is stored in data file pages. So as we know, 8 kilobyte pages, blocks. So we call the page, we will call the blocks as pages in Postgres. An update or delete of rows not immediately remove the rows from disk page. So we know that, if you delete or update, it is not going to what we say. So release that, means remove that. So they will remain ultimately there as dead tuples. Eventually, this row space becomes absolute and causes fragmentation and bloating. This dead tuples causes the bloating in Postgres. So the dead tuples bloating in Postgres is not free space like other databases. Bloating in Postgres means dead tuples. So you can check the dead tuples, how many dead tuples you have from the PG underscore user so statistics table, right? So from there you can find out how many live tuples are there and how many dead tuples are there in the table. And contrary to this, the optimizer statistics, the the usage statistics are accurate. So if the table says you have two dead tuples, that means two dead tuples. For example, so we will check for our T1 table. Okay. So PG underscore stat underscore user underscore tables. Okay. So you have what we need is the rel name. So we need n live tup and n dead tuples. Okay. Select rel name comma. So n live tup n dead tup from pg underscore. So stat tables where rel is equal to T1. So there are four live tuples and there are zero dead tuples. This information is always accurate. Okay. Our PG class, that is optimizer statistics, it will become obsolete or outdated But the PG, this table, PG stat user table, this is always updated in real time. As the queries are happening, this view is updated. So let me demonstrate that. So let me insert two more rows in that, our T1 table. So I am inserting two more rows. So I will check this. Okay, already it is updated to 6. I will check the what we say means our PG class table. So it won't be updated. The PG class table won't be updated. So this is the rel pages, rel tuples. It still shows 4, right? It still shows 4. So the PG stat user table collects the usage statistics. And these usage statistics are for monitoring purposes for the DBS. Okay. And the PG class, the statistics in PG class and PG statistics table, they are for the optimizer and planner. They are not updated. The optimizer statistics are not updated in real time. Got it? The optimizer statistics are not updated in real time. Okay. So, but usage statistics is updated in real time because there is a background process running for this. Okay. So there are 0 dead tuples right now. So what I will do is how we can generate a dead tuple. Anybody suggest how I can generate or create a dead tuple?
Delete the rows.
Delete the rows or
Update also.
the rows,
Insert.
right?
Yeah.
Yes, not insert, delete or update. So if
Update.
you
Delete
delete
or update.
or update, so dead tuple. So I will do both of them. So I am saying, so update T1, okay, set name is equal to, so let us say, so D, so where, so ID is equal to 40. So this one update I am doing, so it should create one dead tuple, right? So this should create one dead tuple. So so we have this. So you can see earlier, the 40 row was, it was in the middle. So, but now the 40 row has come at the bottom because I said, so when you do an update, it will delete the original row and it will insert a new row at the end. So, but this has generated a dead tuple. So let me check. Okay, from here I can check. So whether there is any dead tuple or not. So now it is showing there is one dead tuple, right? So it is showing one dead tuple. So that is what, so you get the dead tuples. So by updating, by the updates or deletes. Okay. So now what we need to do is, so, so how we can get rid of those dead tuples? Okay. How we can get rid of these dead tuples is vacuuming. So if you can vacuum or you can do a vacuum full. So two ways of vacuuming is there. So if you recall our previous lesson in last week, so we have discussed the difference between vacuum and vacuum full. Anybody can tell me what is the difference?
Vacuum means it will not release the space at OS level. Vacuum fill means it will release.
OS of
Yeah,
space
yeah,
to the
it will
OS.
shrink and it will shrink and it will release at OS level. Vacuum fill.
Yes, yes, exactly. So the dead tuple, the space occupied by the dead tuples will be released to the OS. Okay. So so both of them removes the dead tuples. Both of them removes the dead tuples. Okay, that is vacuum and vacuum full. So how to vacuum is just vacuum table name. So vacuum full table name. So just vacuum like that. So run the command vacuum and vacuum full. Okay. So let us do vacuum and let us check the space. The space release is only in the blocks of 8 kilobytes. So it won't release half of the block, 4 kilobytes, it won't release. Okay. So, if you do the vacuum full and, it is able to get, few blocks, few 8 kilobyte blocks. So empty 8 kilo blocks, then they are released to the OS. Okay. So if you have just one block, in that block is used only partially, like our T1 table. So in this case, it won't release any space because it will retain the blocks. Always the size is in block. Okay. So if the block is full, then it will goes to the other block. And after vacuum full, if some 8 kilobyte blocks are emptied, only those full 8 kilobyte blocks are released. Okay. So that is how the space is released. So I will do a vacuum here, vacuum or vacuum full, whatever you can do, because we have only one page for this. So if you do vacuum full, the effect is same. So you can check now. So there are zero dead tuples, right? Okay. So that is how the vacuum or vacuum full works. Okay, there is a command line tool. So if you exit from Postgres, so there is a command line tool called as US in vacuum DB. This tool is very, very effective because you can call it from the Linux command prompt, and you can schedule the jobs if you want to do the vacuuming manually or through cron job. So you can use this utility. So DB help. So all the options are given. Vacuum DB help, all the options are given. Okay. So what we can do here is you can vacuum all databases at once, or you can vacuum entire database, all tables in one database. Like you can vacuum all tables in employees database. So this utility is very useful because the vacuum command vacuums only one table. So, but what we need is, we want to vacuum so many tables at once, like that all the tables in the database we want to vacuum. So if you want to vacuum full, so you can also include this F option. And we will come to the freeze. So what is freeze? We will come later. So number of jobs also. Let us say you are vacuuming 3 or 4 databases, or even just one database, but that database is very large and you want to finish the work quickly. So you can parallelize the vacuum work by using -J option. -J option so launches more than one job, and the vacuuming will be completed. Okay, because more than one thread more than one vacuum process runs, right? So that's the reason, it will be done quickly. Okay, that is J. Oops. So you can also use so dash P. So that is what parallel workers, parallel threads it will use. So quite means, if you are writing a shell script, you don't want many messages to be displayed, right? So that is quite. Skipped lock, there is an option. So that will, if the table, if it is not able to get the lock on the table immediately, it will skip that table. So if you want to vacuum a particular table, so you can give the table name. Okay. And analyze you can do, and analyze only. Analyze means, so it will vacuum plus analyze. Analyze only means it won't vacuum, just it will update the optimizer statistics. Analyze means small z means, it will vacuum the table plus it will analyze the table. So capital Z means it will not vacuum the table, but only recalculates the statistics. So this utility is not only just vacuuming, but also it is helpful in, updating the table statistics, optimizer statistics. Okay. So though two things it will, three things it will be, it is doing. So the other thing is freeze operation. So we will see about the freeze operation, what it means. So the vacuum DB can do all three operations for us. So it can vacuum, vacuum full, analyze. It can also do analyze. It can do freeze. So these are the things the vacuum DB command can do. Okay. And also it allows you to vacuum an entire database or a particular table, full vacuum, only analyze, so or freeze. So you can select so anything and you can perform so all type of maintenance activities except reindexing. Okay, it is doing all the maintenance activities which can be done on the table. So this particular vacuum DB command is very, very useful if you want to perform the manual maintenance, or if you want to script the maintenance activities, you want to create the cron jobs or schedule tasks. So vacuum DB command is a perfect thing to go to. Okay. So how it works is simply you run this command. So it will work. So I am saying DB. So database is Postgres. Table is T1. Okay. So in database Postgres, I am vacuuming T1 table. Okay. So I want to even analyze the table. So I even want to analyze that table. So that means, I just I want to vacuum the table. Okay. And also I want to gather the latest statistics of the table. So I am doing two works here at the same time. Okay. Sorry. We have to give a different port, right? So port 5432. sorry, 5433, that is the port. Sorry. So from here, so vacuuming database Postgres, it has vacuum all the, so T1 table. Okay, because we have given the T1 table, right? So it vacuums the T1 table. So if you want to do a full vacuuming, so you need to just add dash F option here. So the dash F option tells, do the full vacuuming. Okay. So it will give the same output. It will give the same output. Okay. So you are doing full vacuuming here. Okay. So if you want to just do what we say means analyze. I don't want to vacuum, only I want to update the stable statistics. Okay. So I can use capital Z here. So, it will analyze. So you can also use the option verbose if you want to know more about what it is doing. So these are some variations of vacuum DB command. So it is a very helpful command for performing, all types of activities here. Any questions here before we go further? So now let us see about, transaction ID wraparound problem. This problem you will never heard of any other database other than Postgres. So this was a very serious problem in older versions of Postgres. So particularly I started with 7.x version. So we were very vulnerable with this transaction ID wraparound issue. So it may lead to the data loss. So it may lead to data loss. And as a DBA, so you never want this data loss to happen, right? So, the transaction ID wraparound issue was a serious issue in the older versions. But in the newer version, the good thing is, this is not a big deal at all. So, though this problem is there, but it is taken care automatically, and a DBA need not to worry about transaction ID wraparound. Now, so because the auto vacuuming process will take care of this problem. So what this problem is about, the transaction IDs. The transaction IDs. Every database generates the transaction ID, right? So the transaction, so whatever the transactions are happening, so they happen with an identity. So if a user starts a transaction, so a transaction number is allocated to the transaction implicitly without the knowledge of the user, and the user performs the transaction and commits or rollbacks the transaction. When the next transaction starts, the transaction ID is incremented. And if the next transaction starts, again, the transaction ID is incremented like this. the transaction ID is continuously incremented. Okay. So any database does the same thing. They will increment the transaction IDs. So they increment the transaction IDs. Okay. So, and every transaction ID is written with the rows in which the transaction, they are involved in the transaction. For example, so I am doing a transaction like this. Begin. So I am doing a transaction update. So T1, so set. So this is the transaction I am doing. Or, I will write a whole this thing. Set name is equal to where ID is equal to 40. Just now I did this transaction. Commit. So when you do this transaction, this change occurs, and as I said, a dead tuple also comes into picture. So not into the picture, but in the background, a dead tuple is generated. So this change is inserted back into the data file. So all these things happens when I commit and when the process continues. Okay. So this transaction, the whole thing, whether I have used the start, begin or not, so but there will be a transaction ID assigned to this. Let's say transaction ID is 100. Okay, the transaction ID 100 is assigned to it. This transaction. Okay, there is row, this row, the row number 40. So what happens is, along with this row, so there is a hidden column for each table. So the hidden column stores the last transaction ID the row was part of. Usually the row will be part of, two types of transaction ID. So one is, the insert transaction ID, one is, the delete transaction ID, right? So we don't have any update transactions in Postgres. Okay. So, this transaction ID information is saved with this row. So apart from, the data, so apart from the data, so, apart from, this table contains the data like data that is, 40. So D, 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 D. So, you have 30, C, C, C. So apart from all these data, so this transaction ID is also written in a hidden column. So in a hidden column, this transaction ID is written. Okay. So there is a hidden column which saves this transaction ID information, which is responsible for creation or deletion of this particular row. Okay. Now this is a hidden. Every row will have some other, so it's like, like 84 was, let us assume 84 was the transaction ID, which inserted, this row. So 100 is the transaction ID, which inserted, so, the ID 40 row. So this transaction ID column is hidden column. So every row will have the transaction ID which this row was part of. The last transaction this row was part of. Not just Postgres, every database saves this information in a hidden column. For each table, it will add a hidden column. So that saves the information about the transaction ID. So that saves the transaction ID. So the last time the row was involved in that transaction. So in my case, the ID 40 row was involved in transaction 100 last time. So that is what the transaction IDs are. They are saved along with in the table. So for each row, there will be a transaction ID which indicates so what was the last transaction which is performed on that particular row. Okay. So this information is very, very crucial for database to perform recoveries and all those things. Okay. So this information is saved by all databases. So this information is maintained. Okay. So that is very common for all databases. But what is so different in Postgres that we are discussing here? So in Postgres, the transaction IDs are generated by a variable. So it is a 32-bit variable. So it's a 32-bit variable. So it can generate the numbers. It can generate the numbers from 0 to 4 billion. So it can generate the numbers from 0 to 4 billion. So once our pointer transact, it is incremental. After the transaction ID 100, it will generate for next transaction, the transaction ID will be 101. So likewise, it is incremented. Likewise, it is incremented. So 100, 101, 102, likewise, it is incremented. So, it starts from the zero. So zero transaction IDs are performed, when you do the database initialization. So when you perform the database initialization, that is where, the zero transaction ID generated and some internal transactions are done at that time. So after that, one or two, from 3 or 4 transaction ID, it is for user. So this transaction ID starts from zero and slowly increments to 4 billion. So once it is 4 billion, so again, what happens is it starts from 0 to 4 billion. So after that, again, once you have done 4 billion transactions, again, it will start from 0 and this process continues. It is called as wrap around. This is called as wrap around. It is wrapping up, right? From 4 billion, it is coming back to 0 and then again it will reach 4 billion. So again, once it reach 4 billion, again it starts from 0 to 4 billion. So this cycle continues. So that is called as transaction ID wraparound. Okay. So the thing is here, there are some problems when it is wrapping around. So there is some problem it is having in wrapping around. So for example, at any point of time, so let us say you take transaction ID 100. So transaction ID 100 you take. So what Postgres current, this is the current transaction ID. So current transaction is ID is 100. What Postgres can do is it can see, okay, 2 billion in future and 2 billion in past. So it sees 2 billion in future and 2 billion in past. So that is what it is able to see. Okay. So when it is 100, okay, So from 100, 2 billion means, it is in future, it can see about, uh, so about, 1 million. So, 100 less 2 billion. So it is 100 less 2 billion, right? So if there is any transaction, so let us say this has wraparound and there is one transaction, so which was done at the 4 billion, 4 billion. So when the transaction ID is 4 billion. So now that transaction looks like in a past transaction or a future transaction. So that transaction is not visible. Okay. So for example, so it has wrap around. So you take the 100 only. Okay. So, so when it has wrapped around, it will start with 0. So for this 0, the transaction ID 100, so looks like a future transaction ID. It is not the current transaction ID, right? So future transaction ID. So Postgres will not see any transaction IDs beyond 2 billion in future. And it does not see any transaction IDs beyond 2 billion in past. So that's why, what happens, if you have any rows which have not updated for 2 billion transactions, which were never touched, only reads are performed, but no updates or deletes are done. So no updates are done on those rows. So those rows are not visible at some point of time. So due to the transaction ID wraparound issue. So that is the biggest, that used to be the biggest problem in Postgres. So in 7.x version, when I started, we don't even have the knowledge of this one. So I am familiar with SQL Server, and with SQL Server, we don't have any problem at all at that time, right? So I was familiar with MySQL. We don't have any issues with the MySQL also. So nothing like this. But Postgres has this issue. So it can see only 2 billion in future and 2 billion in past. So that's the reason what happens. Some data so becomes completely invisible. So future transaction IDs. So what it will mark them, it will mark them as, illegal, or illegal rows, and it does not count them as rows at all. So that was the issue, and this issue was fixed by doing a freeze. So the freeze is a solution to the transaction ID wraparound issue. So this will solve the transaction ID wraparound issue. So what you need to do is, when you do the vacuuming, so automatically the vacuuming will freeze the rows. So whichever rows are not changed, okay. So whichever rows are not changed for a very long time, right? Those rows are freezed so that, they appear to the queries, and they are not becomes victims of transaction ID wraparounds. Okay. So this problem occurs only to those rows which have not changed for a 2 billion transactions. So for past 2 billion transaction, if a particular row or rows have not changed, so that may cause the transaction ID wraparound issue may occurs to them. But the thing is, so the vacuum command solves this problem. So vacuum solves, it also does the freezing. So the required freezing is done by vacuum. Uh, Auto vacuum. So, or vacuum full. So they will also solve the transaction ID wraparound issue. Okay. So, that is what the freezing I am telling about. Okay. So the vacuum DB utility has freezing. So, you can also use this freeze in for capital F option. So it will do the freezing for those rows which have not changed for a very long time. Okay. So that is about, our vacuuming, manual vacuuming. Let us check about auto vacuuming. So auto vacuuming feature is added in 9.0 of Postgres version 9.0. And since then it is the mainstay. If you want, you can disable auto vacuuming, but it is not recommended. So don't disable auto vacuuming. It is not going to cause any issues. Okay. It is a highly recommended feature because it will do all types of maintenance by itself. Okay. It automates the execution of vacuum, freeze, and analyze. So all three are done by auto vacuum. So if auto vacuuming is running, so you are like, you can just sleep. So don't worry about, the dead tuples. Don't worry about outdated statistics. Don't worry about freezing. Freezing, even if auto vacuuming is disabled, yet now today in the latest version, Postgres will do the freezing, even if auto vacuuming is disabled. Okay. So freezing is no more an issue in the Postgres. It is the issue of the past. Okay. In the latest versions like 13, 14, and 15 versions, freezing is not at all an issue. Okay. So transaction ID wraparound is not at all an issue. So we are discussing it because, still, still, lot of documentation, post, everything talks about it. Okay. So, but it is taken care, completely it is taken care. So auto vacuum can do vacuum, freeze, and analyze all maintenance operations. So auto vacuum consists of a launcher and many worker processes. Okay. TS-EF grep Postgres. So you have the auto vacuum launcher. So this auto vacuum launcher runs in the background, and there is an interval for this. You can change the interval. A DBA can work on that interval, fix that, change that interval. So when the interval comes, it will wakes up and it will start worker processes. Auto vacuum launcher does not do anything. It only starts the worker process, and those auto vacuum worker process will perform the vacuuming, freezing, and analyzing for the tables. Okay. Not all the tables, but there are specific, there those tables which requires vacuuming or freezing or what we say means analyzing. So it will perform as needed, sometimes all three also, sometimes whichever it wants, whichever is needed for the table, so only that much is done. So this particular auto vacuum has been designed so that it does not cause any issues to the transactions. So there won't be any issue to the while the auto vacuum is running, so others can do DML operations. Others cannot do DDL operations, but others can do DML operations while vacuuming is running, analyze is running. Others can do DML operations, but not DDL operation. Okay. So the auto vacuum launcher only launches the workers, and those auto vacuum workers perform the vacuuming. Okay. So there are certain thresholds for this auto vacuum. Okay. Select name, comma, setting from PG underscore settings. where name like auto vacuum. So I am querying the PG settings to know what are the settings of this auto vacuum. So these are the settings related to auto vacuum, and I will go through some of the settings. So I will go through some of the settings. So, one of the important setting is auto vacuum on or off. You can change it using alter system command. So you can set it to off. That is not recommended. So you can set it on or off. Okay. So right now, every Postgres installation by default, it is on. So then you have something like, analyze. So these are the parameters values which are used for analyzing. And there is a freeze and there is a vacuum. Okay. So there is a vacuum. So, these are the parameters, or these are the factors which are taken into, thresholds which are taken into. So while deciding whether a table requires vacuuming or not. So for example, let us say, auto vacuum want to decide whether a table requires analyze or not. Analyze means update statistics. So whether it requires a updating statistics or not. How it is? So, these two parameters are checked. So auto vacuum analyze scale factor is 0.1 of table, percentage of table, 0.1 percentage of table. So that means how much it is? So 10% of table, right? 0.1 means 10%. So 10% of the table, if changes, so, if a table has 1,000 rows, and in that 100 rows are changed, so then this threshold is met. If a table has 10 rows, if one row is changed, then this threshold is met, right? So that is what, the threshold is. So scale factor and 50. So, 10% of the table plus 50 rows are changed. So for example, for example, so let us say 1,000 rows are there in the table. Fifty rows. Okay. So threshold is 50 rows. Analyze is done. if 150 rows are changed, you know. So that is if 100, if the table has 1,000 rows, and there are 150 rows which are recently changed, so then the auto vacuum thresholds are met for analyzing the table, and it will analyze. So it will not just analyze. So this is the minimum threshold. If you want, you can change it. So if you want to increase or decrease the threshold, it is up to you. So vacuum threshold is vacuum scale is 0.2, so that is 20%. So is equal to 200 rows. Okay. And vacuum threshold is, I think, same. So 50 rows. So it is same 50 rows. Scale factor is, 20%. So 50 rows. Okay. Vacuum is done on the table if 250 rows are changed. If 250 changes are done, so it will perform the what we say vacuuming on the table. So the auto vacuum so runs every time, but it does not vacuum each table, all the tables every time. It will look into the thresholds. If this threshold, if analyze threshold is met, analyze is done on the table. If a vacuum threshold of 250 means met, so vacuum is done on the table. If both are met, both the operations are done on the table. Okay. So freeze is threshold is 2 million rows. So 2 million changes. So if 2 million changes, if 2 million changes occurs on the table, let me check whether it is 2 million or not. So this is what freeze max age. So it is 200 millions, not 2 millions. If 200 million changes are occurred in the table, so then the freezing is done. Otherwise, until then, the table does not requires any freezing. So auto vacuum follows these thresholds. Okay. So for analyze minimum, 10% of the rows plus 50 rows, that is, that must be changed. For vacuum, 20% of the rows plus 50 rows. So that should have been changed. And for freeze, 200 million changes should occur on the table. Then freezing is done. So automatically, these thresholds are followed as a DBA. So you can adjust these thresholds as per your requirement. Any questions here? So any questions here? Okay, I'm assuming no questions. Everybody is very clear when the auto vacuum performs the vacuuming, when it performs the analyze, when it performs the freezing. Okay. So as a DBA, you can adjust to those thresholds, you can adjust. So this is what we did right now. So auto vacuum can be disabled by simply saying auto vacuum disable. So, there are few things. So you can disable it by turning it off. Okay. So, one more thing is there. So auto vacuum nap time. So auto vacuum nap time is 60 seconds. That is 1 minute. Every minute it will run. But as I said, every minute it does not vacuum all the tables. It will only vacuum those tables which met the analyze, vacuum and freeze thresholds. And it will selectively perform the operation, either analyze or vacuum or freeze. Only rarely it might need to perform all three, but usually it will perform only one of them usually. So, okay. So, that is what the nap time, if you want, you can increase and decrease, but, let it run for it. It works very well for, it works very well for all types of workloads. So 1 minute is. So there is one more thing called as track count. So this is where the usage statistics can be enabled or disabled. So if the stats collector process is disabled, so you can do that as a DBA. Auto vacuum does not run. Auto vacuum requires the stats collector process. The stats collector process is added for auto vacuum to work. So if you disable auto vacuum, sorry, stats collector, so your auto vacuum also does not work. Okay, so you can disable auto vacuum itself, or you can disable stats collector by disabling this track counts option. Okay, you can also so enable or disable auto vacuuming per table. So don't do what we say means don't disable auto vacuuming for all tables. So if you feel that certain table is heavily used, a lot of transactions are happening on that, so it is getting disturbed by these maintenance activities like vacuuming and all. So you can disable auto vacuuming only for that table. So you can enable and disable auto vacuuming for a particular table. So if you face any kind of problem, I never faced any problem with auto vacuuming, because it does not block DML statements, and applications does not do DDL statements, right? Only DBS do the DDL statements, or only DBS do the DDL statements on production servers. So no other persons do. So if vacuuming is running, only the DDL statements effects. Okay, other statements does not add. The normal DML transactions will happen without any issues, even while the vacuuming is running. Auto vacuuming, freezing is running, or analyze is running. So they don't intervene with DDL statements. But however, if you want to disable auto vacuum, if some tables are there which are getting disturbed because of heavy usage, so you may like to disable auto vacuuming only for that table. So at table level you can disable auto vacuuming for just one table or few tables which are heavily used. So there is a syntax in our lab exercise, you will find this syntax. So how to disable auto vacuuming? So by running the alter table command. Okay, so I will give that syntax. So you can disable auto vacuuming for a particular table. So don't disable for server. So if any tables are having issues, just disable auto vacuuming for that table. So don't worry about it. I have the syntax in the lab exercise. So when we go to the lab exercise, so you will get that. Okay. So that is about auto vacuuming. So the next thing is about indexing. So re-indexing. So you want to re-index for several reasons, right? So you want to regenerate the indexes and all. So if you want to re-index, you have the re-index command. You can run this command. So you can re-index a particular index. You can re-index all indexes related to a table. You can re-index all indexes related to a database. You can re-index system indexes also. Means the indexes created on system tables like PG class, PG database. So those indexes also you can re-index. Okay. So re-index, index and table name, index name, re-index table and table name. So you can use the syntax like this. For example, reindex. So table T1. If any indexes are associated with the in T1 table, all of them are indexed. So all of them are re-indexed. The re-indexed database. So it will re-index. So you can re-index the current database like this. Okay, you can re-index only the current database. I don't know why, it just can't work. So when we say re-index, okay. So anyways, you can also re-index system indexes. So re-index command is useful for, regenerating the index. It is a blocking command. So it will acquire a table level exclusive lock. So you have to do it only in the maintenance hours. You cannot do it in normal hours because it will block DDL, DML, all kind of statements on the table. So it is a pure blocking command. So it will block the table in exclusive mode. Okay. So in an exclusive mode, so others cannot do anything. So be careful with this command index, reindex. And as part of our maintenance, the last one is clustering. So clustering is, the clustered indexes. Anybody knows clustered indexes? What is a clustered index? Anybody? Clustered index. In SQL Server, we have clustered index. I'm not sure in Oracle database. But in SQL Server, we have clustered indexes. In MySQL also, InnoDB also have the clustered index. So clustered index, only one clustered index can exist per table. The significance of the clustered index is the table is physically arranged according to the column on which you have created the clustered index. So if you have created the clustered index on the name column, so the physically the table is also arranged in the order of that name column. Means all the names starting with A will be first and all the names starting with B will be first. So that is clustered index. And that order is maintained. So, after once you create a clustered index, so after that, if you do any inserts or updates, still, the clustered order is maintained. So that is in other databases. But when it comes to Postgres, we don't have any clustered index at all. But we have a concept called as clustering. So table clustering concept we have, index clustering concept we have. So, you can create an index on the table and then what you do is you cluster that table on using that index. So the whole data of the table physically arranged in the order of the index. So, but this order is not maintained if you do any subsequent changes. So again, the clustered order is disturbed. So anyhow, this particular clustering acquires a access exclusive lock. That means, when you are clustering an index, so, the table is locked exclusively and others cannot use the table. So it is completely a maintenance activity, should be done during the maintenance hour. Okay. So how it is done is, so you can use cluster table name using index name. First, you need an index on the particular table. So which tables we have? So T1 table we have. So I am doing some more inserts into it. So you can see that, we have these, this table is there, but, physically the data is not arranged in any order, right? So the physically data is not arranged in the order. So what I can do is I can create an index on, let us say, the name column or ID column, whichever I want. Create index. I'm creating an index on ID column. Okay. So, but yet, the order of the table does not changes. The table remains so unordered only physically. Okay, maybe our what we say means maybe our searches may be fast, but the physical the data is not arranged in the order. Now you cluster this one using this myIDX cluster T1 using myIDX. Okay, so that is clustered. So while clustering, it will acquire a access exclusive lock, that is the highest, strictest lock. And now you see that, the table data is arranged properly, right? Physically, the whole data file is reorganized. So physically, that whole data file is reorganized. So that is what, the clustering is. But the problem with the cost is very heavy, very huge, because the cost is very huge. Why? Because so the table is locked for clustering. But the thing is, if you do any insert or update now, the order will not be maintained. So for example, I am doing one insert, let us say. So I am doing one insert. This insert will not maintain the order. It will come at the bottom. So this is the problem with the clustering. So, it does not have many uses. So it does not have many uses. But anyway, so as we have this clustering, so it is the closest thing to the clustered indexes. So that's what we have discussed it. Any questions regarding the maintenance?
I don't see it is sorted, right? Or it has been.
Okay, first it was sorted when I
Okay.
did the clustering. Okay.
Uh-huh.
But again, when I do any changes, so the order is not maintained. The sort order is not maintained. So that's the reason I am saying, this we are paying a huge price for something, so which is not okay, which is not maintained or which is not permanent. So it is not equal to any way equal to our SQL server's clustered indexes.
But however, without clustered index also it will be fast, right? Because it's very
Yeah, without
challenging.
clustering also, your search will be fast.
Uh-huh.
With clustering, search will be even faster, even more faster. Okay.
Okay.
So, any questions here? So that's about our maintenance, routine maintenance task you can do. So the data dictionary objects related to this are PG class, so PG user stat table, PG stat user indexes. So these are the database objects which are related to, this topic. So, so we are good to move to the next topic. We'll take a break. Yesterday, by mistake, I have given 30 minutes break, 25 minutes break. So actually, our break is only 15 minutes. Okay. So yesterday it was a mistake. So, anyways, we'll take our break and we will come back and we'll resume our session. Two more topics to go. One is data dictionary, which is a small topic, and other one is, so running multiple instances on the same server. So both the topics are small, so we will complete this as soon as possible and we'll go to the lab session. Okay. So till 4:15. So hope everyone is back. So I'm assuming everyone is back and I am starting the session. Okay. And so our next topic is data dictionary in Postgres. So data dictionary is also called as catalog in Postgres. So it is also called as catalog. So, and you can see the catalog, okay, from, so, okay. So let me launch, okay. Let me launch the, what we say means PG admin. So here in PG admin, if you expand any database, so you have the catalog. So you have the catalog. Okay. So there are two things in the catalog. One is information schema. So information schema is mandatory to comply with ANSI standards. Every database should have information schema. So for that reason, information schema is there in Postgres also. However, Postgres actual catalog is PG underscore catalog. All the tables and functions are created in this one. And the PG information underscore schema contains only views. It does not contain any tables. The original catalog is PG underscore catalog. So this contains all the data dictionary objects. So which includes tables, which includes views, which includes stored procedures, functions, all such things. This includes. Okay, PG catalog. So these are all the catalog tables. 62 tables are there. For each of type object type, you have a table. Okay. And there are views. So 72 views are there. So triggers functions are there, materialize views. So all these are, catalog objects. So procedures are there. So functions are there. So, so all these are, the catalog objects. So from Postgres. Okay, this is what the data dictionary is. For each user, any database they connect, so they can see the catalog objects. However, some objects are restricted. So some objects are restricted depending on, some objects are visible only to the super user. Some objects are visible only to those users who have create role attribute, like, the PG underscore auth ID, okay, table. So, but, most of the time, that catalog objects are visible for, all the users. Okay, whichever database they connect. So you will see the same catalog. So whichever data, especially the global objects, like, the PG database, PG auth ID, PG table spaces. So these are the three global objects. So they are same in all databases. But whereas PG class is specific to the database because it contains the information about the table spaces. PGNS space, namespace, that is specific about schemas, that is also specific to database. Every database will have, so PG class, but the information in the PG class differs from database to database. If you connect to the Postgres database in PG class, you will find information about T1, so orders, and the So the test table. If you connect to MyDB, so whatever tables you have, only those tables information you will find in PG class. So you will not find any information about, tables from other databases. So PG class is specific to database. PGNS space, namespace is also specific to database. So some objects are specific to database, but PG database, PG underscore table space, PG underscore auth ID, they are global objects and they are visible in all database with the same data. Okay. So that is about, the catalog. Okay. That is about the catalog. Catalog is a special schema which contains the data dictionary objects. Okay. So what we have in the data dictionary objects, let us see. So data dictionary object have, lot of things like PG underscore tables. We also have class, right? PG underscore class to view the details about the tables, but we also have PG underscore tables. It is a view, it is not a table. Okay. So you can see D. So PG underscore. So this is what you will get. Schema name, table owner, table space, has indexes, has rules, has triggers, row security. So this information you will get from, the PG table. So it is a quick thing to, check what is the schema name, what is the table name. So who is the owner of the table and which is the table space. So if I do select, okay, schema name, comma, table name, comma, table owner, comma, table space. So from PG underscore tables. So our test TBS table Y is there. Yesterday we created it to test our table space. It is showing that it is in. So my TS, okay, table space. If the table space is empty, so that means it is in the same table space as the database itself. So whatever be the database table space, that is the table space for this table also. Okay, like PG auth ID is there. So PG auth ID is a global object. Auth ID means it contains the details about all the users. It is a global object. So the all the global objects will have will be there in the PG global table space. Okay, PG global. Yes, yesterday when we learned about the table spaces, we have learned about this table space also, PG global. So PG global is the table space for all global objects. Okay. Where so you can simply do this query to find out all the global objects we have. So PG auth ID, the user information subscription, this is about, logical replication. PG databases, this is about the databases. PG DB role setting, so for which database, which role setting, that is also a global object. PG table spaces, PG auth members, the user membership. So PG, okay, SH depend. So PG SH description, replication origin, and SH sec labels. So these are all what we say means these are all the global objects which will be there in the table space PG global. Okay, rest of the data dictionary objects so are specific to the database and they reside in the table space of the database. For example, we have MyDB table, MyDB database. So MyDB database, let us say, is created on a particular table space. The PG class table of MyDB will be in that table space. Okay. So that is the difference between, different, the catalog objects and, the global objects. So specific to database object, data dictionary objects from PG global, as well as, the table space of, the database. So from in both they will reside. Okay. The PG tables gives a lot more information about the user tables and system tables. So PG constraints, a list of constraints. So you want to know what constraints you have. So you can list the constraints. PG indexes, list of indexes, PG triggers, list of triggers, PG views, list of views, and PG class stores information about all objects like, so tables, indexes, sequences, views. All these objects were part of this PG class. And PG class is a table, and all these are views which are derived from PG class. So PG class contains information about the tables, information about the indexes, information about the sequences and views. Means, the PG views, PG indexes, PG tables. Okay, all these are, views from the PG class table. Okay, they are the views created on the PG class table. Okay, so that is what PG class is a table, and they are the views. You can check out PG tables. So it is a view, it is not a table. Whereas PG class is a table, right? So both of them are in the catalog. So both of them are in the PG catalog, but that is a table and this is a view. Always you should know the difference. Okay. So these are some of the information views or tables we have. There are some functions which are provided. A lot of functions are provided. So not just some functions, a lot of functions are provided. So let us say PG postmaster start time. PG underscore postmaster underscore start underscore time. This is the function. Select PG underscore postmaster underscore start underscore time. Okay, this is the time the postmaster was started. So it was started on 17th. Okay, so at this time it was started. Okay, so you also have select. So it is 18, almost 24 hours earlier it got started. So since yesterday it is running. So yesterday 3 o'clock I think I started it. So still it is running. So that is from where you can find out. So what is the start time of the Postgres Postmaster service? So current database, current schema. So you want to know, so you can know. And the client address, client port, server address, server port. So these are also version also you can know. So there is a version. So the version so tells us the version of Postgres. So these are some system information functions. Other things are current user, session user, current schema. So current setting, set con, we can also change the variables. So you also have the set command, right? So there are other things like, you have cancel backend. So cancel backend means, you whatever the query the user is running, terminate that query. Okay, whichever query the currently a particular user is running, so terminate that query. Okay, so that is what the cancel backend means. So how to find which query the user is running? So there is one more table, there is one more view actually. So we will learn more details about this view tomorrow. So pg underscore stat underscore activity. So this view tells us what is happening currently on the server. And there is one thing called as query start. So this is the time when the current query has started, and it will also give query, so the query itself. Okay, use name. So and PID also it will give. So PID, so I will write a query, select PID, comma, use name, so that is username, and query, what is the query start. So when the current query has started, query itself from pg underscore activity. So it will tell us, probably I should do an expanded view so that, we can get properly. So what it is saying, the PDAP, so username is Postgres doing nothing. Okay. So I will do one query actually. So on MyDB, I will connect to MyDB and I will launch the query tool. And here I will run the query. Select pg underscore sleep. So for, let's say 300 seconds. So for 300 seconds, it will 5 minutes, so it will run. Okay. So now what I will do is I will just come back here and I will run this command. Okay. So you can see this query is running, right? So this query is running, the PID is 7747. So I can kill this PID using this function. So PG cancel backend, PG underscore cancel underscore backend, PG underscore cancel underscore backend. So I can give the PID. So the PID is what? So this one, this is the PID. Okay. So this is how you can kill the current query of any user. So, the statement terminated due to the user request. So this is what you get because, I have terminated the query. So this is how you can find out. So from, the query. So this one. So which user is doing what activity, and you can kill the current queries also. So tomorrow we will learn more elaborate about monitoring lessons, have more information. So, these type of things are there in monitoring lesson. Okay. So this function is very useful to kill, long running queries. As a DBS, sometimes you are required to do this long running queries, and you can do this way. This, you can find out. So with this one, with this query, and also you can terminate those long running queries. Okay. Sometimes what happens, some queries will become stale. They are no longer running, but they will be there showing as running for hours together. So it is best to delete, kill those queries, right? So you can do, and there is a terminate backend. Terminate backend means close the user session. So the user session itself is killed. So PG reload configuration, so that reloads the configuration. So without using the PGCTL, so from the PG command line, you can reload the configuration by saying PG underscore reload underscore conf. Log rotate log file, so it will close the current log file and starts a new one. So start backup and start backup, stop backup, we will learn. So when we go to the backup, so this is something, okay, PG star size is a very, very useful function. So you can replace this star with the one like table space, database, relation. So you can replace the star with any of those values, and it will give you the size of them. Okay, that object. For example, PG underscore table underscore size. So T1. So the size of T1 table is this one. So PG underscore database underscore size. So I am giving, let us say, Postgres database. So this is the size. I will turn off the expanded display. So this is the size of the database Postgres. Okay, it is accurate, but it is not that friendly to read, right? So what we can do is we can wrap this in another function. PG underscore size underscore pretty. So you can pretty the output size only. Now it is saying, so now it is giving accurate size. Okay. So, the size function is very useful. So you have to replace that, instead of database, you can put a table. So you can put other objects which requires the size. So which takes the disk space. Okay, PG underscore column size. If you want to know the size of a particular column, so you can do that. So for example, select PG underscore. I think, I have, I think I didn't remember the syntax of this function. No function matches the given argument. You might need to add explicit typecast. So, okay, column underscore size, right? Okay, so 5 bytes this column. Okay, so this is what you can find the column size also. Okay, so oh, okay, so you can perform some operating system task like ls command, cat command, read a file. So pgstat, there is a Linux stat command, so it will do this stat file. So these operations are restricted to super user. Normal users cannot do this. So lsdir means it will do the directory listing. So read file, so it will display the content of the file. This read file is very, very helpful. So most of the time, this read file is very, very helpful. So for example, if I had given select, so pg underscore read underscore file, okay. So I am giving where, so the file name where lib, so PGSQL, so 14 data, so PG underscore HBA underscore conf. So let us say I'm giving this file. So I want to read this file. So, okay, PG and okay, HBA.conf file, sorry. So it will display the contents of that file. It will display the contents of that file. So this particular function may be so super useful. So if you want to see the content of a particular file, we'll see how it behaves if I paste the same command in our PG admin. But PG admin, right now PG admin is so running on the same machine. So where Postgres is running, so I'm not sure how it will behave. So if your PG admin is running on a different machine. Paste. Okay, it also did. So, but in a single line. Okay. So anyways, this is something you can make use of. So to read any file while in that particular, while connected to the Postgres from PSQL. So it works perfectly. There are information views like, PG stat activity. Just now we have seen PG logs. Tomorrow we will see more about PG logs. So tomorrow's topics include this PG logs, but it contains the current logs, both allotted logs, that is, the granted logs, and the waiting. So the users who already have the log and the users who are waiting for the log. So all the details you can find from the PG logs view. PG stat underscore database, details about the database you can find from this view. PG underscore stat underscore user table, already we have seen to find the dead tuples and live tuples. So how many inserts occurred? So when was the last vacuuming is done on the table? When was the last? So freezing is done on the table. All such information is here. So in this PG stat, so PG stat user underscore views. So that is about, the data dictionary in Postgres. Any questions you have regarding the data dictionary? So I am taking that as no question. So it is a very straightforward topic. So tomorrow we will do this monitoring lessons. Today, so we have one more topic to do today, which is practical topic. So that is running multiple instances of Postgres. So how to run multiple instances of Postgres? Each instance each instance requires a data directory. Okay. Each instance requires a data directory and port. Optionally, service user. So OS user. So optionally service user or OS user. So this is optional. Okay. So you can also run multiple instances with the Postgres user itself. So however, it is not recommended. So always use a separate user. It is highly recommended. Though it is optional, it is highly recommended that every instance should run under a different OS user, different OS user. The current instance of Postgres is running in Postgres under Postgres user. Okay. So apart from that, if you want to run another Postgres instance, run it in another user. Okay. Create another user and run. So in that user. Okay. So now what we will assume is, let us say, so we want to run a second instance. Second instance for, so let us say sales team. So the sales teams requires a second instance of sales application requires a second instance of Postgres. Okay. So they don't want to share this because in Postgres, what happens is the databases are, they are not very, you cannot manage them individually. So recoveries and all are intertwined. So, you cannot recover a particular database. So you have to perform full recoveries. So, that's the reason, every application may want a separate instance. So what we do now is, so we will run this second instance. So how we are going to run this second instance is, so data directory. So it is the, so we'll start with the service user. Service user is, so sales. So this is the service user I am planning to use. And this is a OS user. Okay. So data directory. So I want the home directory of the sales. Okay. So that is, it should be something like this. Okay. Data directory of, this. So that is the data directory port. I want to run it as 6432 port. So this is what I want to run. This is what I want to run my second instance. So I want to run my second instance. So as this one, so I will create a OS user sales. So under the home directory of the sales user, so I will have my data directory and I will run the second instance on port 6432. So that is what my plan is. Everybody is okay with this plan? So already we
Yes.
learned that already we have learned that um, so installation goes into USR PGSQL dash 14 or whatever version is. Okay. So 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 the installation is common for all what we say instances. So it is common for all instances. So there is no need to perform another installation. So Postgres can manage that. With the same installation, you can run hundreds of instances, not just two. You can run as many instances as you want. Okay. So apart from this installation, there is a var run directory. So there is a directory called as var run. So Postgres. So var run Postgres. So this directory is also used by the instances. How they are using, let us check out. Okay. Here. Exit from Postgres also. So in admin user, so I am becoming, super user. So I am root user now. So if you go to var run, so so this is the directory where it will save some status files. So Postgres, the owner of this directory is Postgres and Postgres. So, the status file is saved in this, and currently this directory is writable only to the Postgres OS user. What we want is we want this directory to be writable to our sales user also, right? Because I want to run my second instance as sales user. Anyways, I want this directory to be writable to the sales user. What I will do is I will create the sales user with the group Postgres. So this is the owner Postgres and this is the group Postgres for this directory. Okay, what I will do is I will give the right permission on the group. So I will give the right permission on the group chmod g plus w on what we say means Postgres. So I have given the right permission on for the group also. You can check out. So then I can create the service user. So once I complete this, I will give the lap time so that you can also, so what we say means perform these exercises. So I have given the right permission on that directory. So I will create one user. User add is the command to create a new user. So I am creating a new user. called as sales. So the group of this user is Postgres. So the users group is Postgres and the user name is sales. So this user I am creating. Okay. So you can check out ID sales. So what it is saying, the username is sales and the group is Postgres. The user is part of this Postgres group. Okay. So this is how you can create a user. So it is all Linux skills. So these are not database commands which I am running. Okay. So I have my first task done. So that is, my service user is created. So I got my service user. So I need this data directory also. So let us do first something. So let us set a password for that service user. Sales. Sales. So, I have set the password as sales only. So, I have set the password. So, my service user creation is successful. Now, what I will do is, so I will exit from here. I will simply say sudo su sales. So I am becoming sales user now. Okay. So I have become the sales user. So I can become from the root user also. So I would have done that as well. Okay. So anyways, so now who am I? So I am sales user. I am saying mkdir data. So you can see, so this data directory has loose permissions. So I want, 700 permissions on data. So you can see 700 permission on data. So far nothing on Postgres command, all these are Linux commands. So once the data directory is set, once the data directory is set, so what you can do is you can, once the data directory is properly created, so you can initialize the database. So our second step is also over. So this is also done. Okay, so the third step, we have to set it in the PostgreSQL.conf file. So you don't get the PostgreSQL.conf file until you initialize the database. So we have a command. So we need to set the path variable here. So there are some variables we will set. So bash profile. So the variables I am setting is export path. So is equal to, so USR, okay, PGSQL-14, the same path. So bin colon dollar path. So I am setting the path. I will also set the data directory. PG data is equal to home sales data. Okay. So these are the two variables I am setting. These are the two variables I am setting, path and data, and I will source this file. So once it is set, so you have a command, I need DB. This is a Postgres command it is. So to initialize the database, which I need DB. So it is in USR PGSQL 14. So I need tab. So you can do I need DB help. So it has a lot of what we say means option. So one of the option is, okay. So while initializing, you can set, okay, already we have set the data dir. So, and you can also set username. So this will be the super user. By default, Postgres is the super user, right? By default, Postgres user is the super user. So what I want is, I want this user. So I want, a different user, not the Postgres user. So this is the option, U option is there. So, it will set the username. So what I'm going to do is I am going to run this initdb command. So by giving the data directory as home, so sales data. So this is the data directory and I am giving the user, the super user for this instance is sales. Okay. The super user for this instance is sale. So if you want, you can use any other user or you can also retain Postgres as well. Okay. So initialize the database. So initialization is done. Okay. It is. Oops. Okay. So initialization is successful. So this is the first step. So first database activity means Postgres activity I did. So far what I did was Linux activities, right? So initdb is the first database command I have used here. So our database has, so our database is up and running and not up and running yet, but it is initialized. You can go to the data directory. So you can check, okay, all the files owned by sales user and they are, the group is Postgres. So that is the way we configured. So that is the way we configured, right? So now what I am going to do is I am going to start this pvctl start, not start because I need to change the, so I need to change the port number. I need to change the port number. Okay. So I am uncommenting listen addresses. Okay. So, and I am uncommenting the port number also. And I'm changing this to 66432 is the port. Okay. Cat So I have set the port number. I have set the port number. So once I have set the port number, I am good to start. So I can say PGCTL start. Okay, I think somehow so PGCTL while copy pasting some of the commands got copy pasted. So the server is started. So so this is how you can start the server. Okay. So what I need to do now is I need to connect. Same PSQL command you need to use. So 6432. So that is the port. So 6432 is the port. So just give that port. So you will be connected. Okay. And also, so you should be connected. Uh, so So Postgres database. So we are connected to Postgres database. So we also need to give the database name Postgres. Okay. So once you are connected, so you do two more things. One is, what you do is you rename this database. And other thing is, you set a password. Alter user sales. Okay. With password secret. Okay. So I have changed this. And also what I'm going to do is, so I am going to rename this database. Alter database. Okay. So Postgres. Rename to sales. So I'm also renaming the system database Postgres to sales. I need to connect to a different database to do this one, but I'm going to do this. Okay. So I have changed. So it looks like a perfect installation with complete sales user. So I'm exiting from here. I will connect to template one. So then I will run that rename database command. So the database is also renamed. So, you have the super user sales, the service user sales, and, you have, so everything perfectly so done. So then what you can do is you do an L here, \L. You can say sales template 0, template 1. So this sales is the equivalent of Postgres database in, okay. So simply now you exit from here. So you do PSQL. So and port you need to give 64. So for some reason I was dropped, so I'm not sure why. Anyways, so we will go to the lab till 6 p.m. and we will do two files today. So that is 7 and 8. So maintenance.txt and multiple instances.txt. Okay. So these are the two files you are supposed to do for today's. So lab till 6 p.m. So we have another 40 minutes. So that should be enough. Okay. So I'll take a 5 minutes break. I will be back in 5 minutes. So you start the work. I will be back. So once I am back, I will announce. I'm back. I'm around the desk, so if you need any help, you do let me know.